Good morning. In this video, I'm going to review how to factor a polynomial just using the greatest common factor. This is kind of like an intro lesson to factoring quadratics and trinomials in general. So, one thing you have to keep in mind is that when you're factoring, think of dividing because that's what you're really doing. Factoring is kind of the reverse of doing the distributive property or foiling. So, when you do the distributive property in FOIL, you multiply. So, we're going backwards, you're going to be dividing. So, with that being said, you want to look for, as far as the number is concerned, what's the largest number that can divide. In this example, 6 and 24. Well, that would be 6. 6 divided by 6 is 1, and 24 divided by 6 is 4. And then as far as the variables, you want to take out the smallest variable from each one. So the smallest variable or exponent is, for this problem, is going to be x. So what we're doing is we're going to factor or divide out 6x from 6x squared and negative 24x. So if we take out the 6x squared, the 6x from 6x squared, we only have x left. And if we take out the 6x from 24x, all we have is 4 left. So I'll show the work for that so you can see. But if we do 6x squared divided by 6x, the 6's cancel, and we only have 1x left. So that's where that 1x came from. And if we do negative 24x divided by 6x, the x's cancel, and negative 24 divided by 6 is negative 4. That's where the negative 4 comes from. And now it's factored. If you wanted to check your answer, you could distribute the 6x back in, and we'll end up with 6x squared minus 24x. So that's how you can check your answer. Right, on this next problem, you want to find the largest number that can divide 20 and 44. And that would be 4. And we have x squared and x, so I can take an x away from both of those as well. So if I do 20 divided by 4, that gives us 5. And x squared, I took one x away, so now there's only one x left. And then for the 44x, if I do 44 divided by 4, that's 11. And I already took the x out here. It's down the outside, so there is no x left. So that would be the factored form for this polynomial. 4x times 5x plus 11. This one could be a little intimidating because this has 2 variables, but that's okay. You just do each piece at a time. Let's look at the number first. The largest number that can divide both 3 and 15 is 3 itself. And then if you look at our variables, the smallest variable for for x is 3. So we can take out an x cubed. And the smallest variable for the y's are, I keep saying variable, the smallest exponent for the y is y squared. So we can take out y squared from both terms. So I took the 3 out already, so the 3 is gone. X to the 4th and x cubed, so I took out 3 of the x's, there's going to be 1 x left. And for the y squared, I took that out already, so it's gone. So the first term, all I have left is x. Now for the second term, if I do 15 divided by 3, I get 5. I took out the x cubed already, and I have 1 y left from the y cubed, so I took out y squared. So the factored form of this one is 3x cubed y squared times x plus 5y. for this one's just a little easier than the last one. If you look at the numbers, we got -2, 14, and -6. So I can take out a -2 or divide -2 by both of those. And my smallest variable for m, or exponent for m, is just 1m. So I'm going to take out -2m. So if I do -2m to the fourth divided by 2m, or -2m, excuse me. So the -2 is canceled, and m to the fourth over m is m to the third. So I get m to the third left. If I do 14m squared divided by -2m, I get -7m. So we're going to put -7m. And if I do -6m divided by -2m, the m's cancel. And -6 divided by -2 is a +3. So I put +3. And that's my factor form. All of this over here is scratch work. I didn't do that for every problem, but this is things you can figure out in your head. I mean, I wouldn't expect you to just write all this out, because once you do it enough times, it's simple. You do it in your head. But that's it for this video. The next video will delve into difference of squares. So I'll see you then. Thank you for watching.